All right, good morning to you. How are you doing today? Welcome to one of our sessions. You're welcome. You're welcome. Today we're going to be looking at based on the demands. We want to discuss some few things on the subject of chemistry, and specifically we are looking at chemical combination, electrovalence, or ionic bonding. All right. So let's start. Let's begin with introduction. Okay, so we realize that chemical bonding, particularly electrovalent or ionic bonding, is a fundamental concept in chemistry. It explains how atoms of different elements combine to form compounds. The understanding of ionic bonding has evolved over centuries, with contributions from various scientists like Gilbert Lewis and Linus Pauling. So, ionic bonding plays a crucial role in the formation of many compounds, including salt, oxide, and hydroxide. And this works also for many of the compounds we actually use in our everyday life. For example, water. Okay, for example, talk about we use let's say sodium chloride. Yeah, that's for our salts. We use calcium oxide. We use calcium carbonate in the production of cement. We use water, which is H2O, of course. Water is a combination of oxygen and hydrogen. So many of the things we see in every life as a result of a bonding of one element or the other. So under chemical combination, we'll be looking at, first of all, in this part, we'll be looking at electrovalent or ionic combination. Though under chemical combination, we have electrovalent or ionic, we have covalent, and under covalent, we have ordinary covalent and coordinate or dative covalent bond. So let's head right into electrovalent or ionic combinations. Now let's look at the principle that guides ionic and or electrovalent bonding. Now number one is the ion formation. Ion formation. What do we mean by ion formation? Now listen, metals tend to lose electrons and form positively charged ions, which are called cations. And I believe from our knowledge of our periodic table, we know that we have seen some things like this before. Na+, we've seen some things like Mg2+, we've seen things like oxygen carrying a 2-, we've seen chlorine carrying negative. So all these are what we call their ions, and ions as a result of the addition or the loss of electrons from a stable atom. So that is one of the principles we're going to be looking at. Okay, so metals actually lose electrons to form what? Cations. Cations are the positively charged ions, just like I have here, while the anions are the non-metals form what? The non-metals tend to gain electrons and form negatively charged what? Ions. And these are examples here. So these are positively charged ions or cations. That is this, and these are negatively charged ions or anions. All right, so that's number one. So secondly is the octet rule. Now octet rules, atoms tends to gain or lose or share electrons to achieve stable electron configuration similar to those of the noble gases, typically with 8 valence electrons. So octet rule, from the word octet, octet signifies 8. Okay, it means that atoms that has either 2 electrons in the atomos shell or 8 electrons in the atomos shell are considered as what? Stable. We're going to be looking at that soon in our example. And the third principle we'll be looking at is that electrostatic forces. Now, the electrostatic attraction between cations and anions form what? Ionic bonds. As we know that what? Unlike charges, they actually what? Repel, right? So which means if I have a positively charged ion and a positive charged ion beside each other, what will happen? They will move in opposite what? Direction. But I know that like charges, oh, excuse me, sorry for that. No, that's not correct. That's not correct. Unlike charges actually attract. Unlike charges attract, sorry, that's a mistake. Unlike charges attract. That is, if I have a positive charge ion and a negative charge ion, what happens? They come towards each other. Okay, so but like charges, they actually what? Repel, which means they move away from one another. So if I have two positively charged ions or two negatively charged ions, what happens? This will move away from each other, and this will also move away from each other. So note that very clearly. And also we go to the lattice structure. So ionic compounds usually form crystalline lattice structures, each with ions surrounded by oppositely charged what? Ions. Okay, and we're going to be looking at that also when we enter fully into when we look at into bonding properly. But let me just give a short description of the crystalline structure of, for example, like let's say sodium chloride. So let me just use, let me use the blue to represent let me just do like this, blue, and then I represent another one by just, let me say, black. Okay, so we can have this, we can have this, we can have this, and then we can have also, so we can see that this structure, this crystal lattice structure, is formed as a result of what? The combination of two different atoms. So I can say if this one represents, let's say, the sodium atom, and this black one represents, let's say, the chlorine atom. So this is the crystal lattice that helps in the formation of that particular electrovalent or ionic compound. So let's move on to the next slide. Now let's look at sodium chloride. How do they actually form bonds together? Now, sodium has an atomic number of 11. So which means I will have what? 2 innermost shell with what? It as a second, and then 1 as a outermost electron. So I can draw it like this. Let's say we have 2, 8, then I have 1 electron in the outermost shell. And also we have chlorine. Chlorine has an atomic number of 17, which means I will have 2, 8, 7. So which means it will have 2, 8, then 7 electrons in the outermost shell. That's 1, 2, 3, 4, 5, 6, 7. Okay, so what happens when we have a transfer? So as we can see that this one actually has a free electron in the outermost shell. What if I bring this one to join with this so that chlorine can complete 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outermost shell, so that at the end of the day both become stable? And let's look at the final result of this combination. We'll realize that at the end of the day, sodium will now be left with 2 electrons in the outermost shell with complete 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you see? Because it has released one of the atoms, the valence electron, which is the outermost electron, to chlorine, and therefore chlorine 2 will now have 2, 8. Now instead of 7 in the outermost shell, now it will has complete what? 8. 1, 2, 3, 4, 5, 6, 7, 8. So at the end of the day, both atoms are what? Are balanced. And at the end of the day, here we have 2, 8, and here we have 2, 8, 8. So what do I mean by that? Now let's now see. Here we have a sodium ion. Okay, if you look at the way it is now, since sodium is a neutral atom here, it has lost an electron here. So here we have sodium what? Ion, and in this case we have our chloride ion. Okay, so and due to this we can have sodium and chloride ion to give sodium chloride, which is our stable compound or ionic compound, which is our table salt. Alright, secondly, I will move to the second compound we have here, which is the magnesium oxide. So let's look at magnesium as well. So I know that magnesium actually has an atomic number of 12. So that will be what? 2, 8, 2. That means it actually has 2 electrons in the outermost shell. 2, 8. Then we have 1, 2. Okay, and then we also have the second element. We have oxygen. Oxygen has an atomic number of 8. which is 2, 6. It means it has 2 in the normal shell, and we have 1, 2, 3, 4, 5, 6. As you can see, it's not up to 8 in the atomos shell. So what we are going to do is that we are going to effect a transfer from magnesium atom to the oxygen atom. So there will be transfer 1 electron here, and the valence electron here also moves to this, so that at the end of the day both atoms can achieve a balance. Are we together? Okay, so let me bring it together. So magnesium ion now becomes there's 2, 8. You know, it has lost that electron in the atom shell, so I can maybe draw it this way. 1, 2, then I can draw 1, 2, 3, 4, 5, 6, 7, 8, which is complete. So this is the magnesium ion, and that is also the Mg2 plus, right? It has lost the 2 valence electron. That's why we have the 2 plus there. And also we have oxygen here, which is now also 2, 8. You see they have complete octet structures. So here I have also 2. So here we have 1, 2, 3, 4, 5, 6, 7, 8. You see now? So here we have our oxide ion, which is O2 minus. So breaking all together, you know, I could actually say Mg2 plus the oxide ion should give me a stable magnesium oxide compound, which is very, very stable. Very, very stable. Alright, so that is an ionic bond between magnesium and oxygen to give magnesium oxide. Now, what are the characteristics of ionic or electrovalent bond? Because of the strength of this bond, they are usually have a very high melting point. For example, sodium has a melting point of 1467 degrees Celsius. This is the boiling point. Boiling point, and that is very high. Okay, boiling point is this, and melting point for sodium, melting point is also very high. That's 801 degrees Celsius. So for reference purpose, know that water boils at 100 degrees Celsius. So this is almost like 8 times the temperature of boiling water. Very, very hot. And also solubility. What do we have to say on solubility? They are actually very, very soluble when dissolved in water. They are very soluble when dissolved in water. And also electrolyte. What does it mean when I say electrolytes? Electrolytes are actually liquids that conduct electricity. Why do they conduct electricity? Liquids that conduct electricity. Okay? Conduct electricity. Why is this so? Because they are able to actually break down into what? Ions. For example, the sodium chloride we mentioned, they can actually break down into sodium ions and chloride ions all together. So that is the characteristic. Number 1, high melting and boiling point. 2 is the solubility. They readily dissolve in water. And number 3, they form electrolytes. Okay, and next we look at summary. Ionic bonding is a type of chemical bonding that occurs between atoms of different elements. Involves the transfer. Remember, ionic bonding involves transfer of electrons from one atom to another, resulting in formation of ions with opposite charges. And the electrostatic force between this bonding, they are very, very strong, and that is what makes them to have that high boiling and melting points, and leading to the formation of an ionic compound with characteristic properties which we listed above. So to ensure that you have a good understanding, I would love you to actually do this little assignment. Write the chemical formulas for the following compounds: potassium bromide, magnesium oxide, and aluminum sulfate. Let me see how you're going to do that. Let me see how you can check your understanding. Okay, but I think this one, sulfate, yeah, well, this one will be a little technical, but you can do a little more research on that. God bless you, and also the second as well. Thank you.